Okay, now for perfect competition, we're going to show a profit. So again, we're just going to draw the two graphs. This is quantity and price. So just the typical supply and demand. Find where they intersect. And this is the price that you're going to sell at. So the demand is constant since you're always selling at the same price. And like we talked about earlier, demand equals MR because demand has a slope of 0 and MR is just twice the slope of demand. So since we're operating at a profit, the average total cost is going to be below the marginal revenue. Okay? Average total cost. And then the AVC just needs to be below the ATC. Average variable cost. Okay. And then the MC needs to intersect both the ATC and the AVC at its minimums. This is your marginal cost. And then now, to find our optimal bundle, we figure out where MC and MR intersect, which is right there. You bring that down to where it intersects the Q axis, that is Q star. And then this is P star. Since it's from that point, and then you bring it over to the P axis. Alright, so now you're going to take it from the optimal bundle and bring it down to where it intersects ATC, which is right there, and draw that line over to the P. So the area beneath the MR, this is your revenue, and then the area below where it intersects the ATC, this is how much it costs. So the difference between the red and the yellow, that is what is this box. And this is the profit. Since the revenue, the red, is larger than the cost, which is the yellow. Okay, so now we're going to show the shifts which occur since this market, let's say wheat, has a profit. A lot of the farmers from corn, which we're operating at a loss, are going to move into this market. So the supply is going to increase, S bar. So that has a new point of intersection. You do the same thing, bring it over to the second graph, and draw the new demand, T equals MR. Okay, and so something you have to be careful about is when you draw your new demand and MR line, you need to make sure that you draw it to where the MC, ATC intersect, which is right there. I drew it slightly below just because the stylus is kind of big. But the reason you have to do that is so you reach the point of equilibrium where so many people move into the new market that there's neither a profit nor a loss. So the reason why is where MC equals the new MR, that is your new optimal bundle, correct? So that is your Q bar. And as you see, like, the area below the new MR line and the area below the new ATC line is equal. So there's neither a profit nor a loss, and it's at equilibrium. And so don't forget to draw your arrows to show the shift from the supply and all the other lines. Okay, so we're going to go over perfect competition, which is the 4 graphs, 2 for a loss and 2 for a profit. And we're going to go over loss first. So just start off by drawing your 2 axes. Okay, so this is Q for quantity and P for price. And then you start off by just drawing a regular supply and demand relationship. So this is where they intersect. This is P star. And what you're going to do is you're going to draw a line through that to the other graph where it shows you where the demand curve is. And the demand is going to equal MR in this because demand has a slope of 0 and MR has twice the slope of demand with the same y-intercept. So that's why they are the same line in this situation. And since we're trying to show a loss, the average total cost is going to be above the marginal revenue. because that just makes sense with having the cost above the revenue if you're going to show a loss. So this is average total cost. And then the AVC doesn't really matter too much where you put it as long as it's just below the ATC. And then you draw the marginal cost through the minimum of the ATC and the AVC. Okay? And then to find your optimal bundle, you figure out where MC and MR intersect, which is right there. Okay? And then you draw a line down to the x-axis, which is Q, and that is your Q star. And also at that same point, you bring it, like in the same optimal bundle, you bring it over to the y-axis, and that is your P star. Okay? And then what you're going to do is you're going to go again from the optimal bundle and bring that line up to the ATC to find the price, okay, at that bundle. And then you bring that over to the y-axis. Okay. So the area underneath the MR, right here, this is all the revenue that you're making, okay? And all the area underneath the ATC line, this is all the costs that you're spending. So the difference between the yellow and the red, which is right within this square, this is all the loss. Since the yellow, which is the cost, is greater than the revenue, the money you're making, so that is why you're operating at a loss. So now, since this market, let's say it's corn, the people who are in it are operating at a loss, so they want to move to a different market where they can at least make more money. So since there's people leaving, your supply is going to go down, S bar, okay? So now you have a new point where S and D intersect, and then you're going to bring this line, just like you did earlier, over to the second graph, and then draw your new demand and MR. D bar equals MR bar. Okay? And then now you're going to figure out where MC and MR intersect again to find your optimal bundle after the shift, which is right there. Do the same thing where you bring it down to the Q axis, and this is now your Q bar. Also, we need to show the shift from the Q star to the Q bar, the shift from the S to the S bar, and the shift of the demand and MR, which I showed right there. Okay, and that's it now, because the area underneath the ATC and underneath the new MR is equal. So it's at equilibrium. There's neither a loss nor a profit.